Well, welcome to the end of the day. Have you had fun? Have you enjoyed yourself so far? So in the next 5 hours, I'm going to teach you about API design. Yeah, no, not really. So this is the solo thing for comments, but I suspect the way I work, there won't be time for comments. So just come and find me. I'm here all day tomorrow as well. Right. So my name is Steve Poole. I used to work for IBM, used to work for Red Hat, used to work for Sonatype. I'm currently looking for opportunities. I do a lot of minimal sort of consultancy stuff. And I talk about security and I talk about cybercrime. And amazing, I talk about API design. Because there is a connection. And I've always had a passion for software architecture. But there's a little bit in here that will explain why I'm talking about this. Right. So we're going to do some background. I want to talk to you about common mistakes and things, and I want to talk to you about how to use modern Java to get more resilient APIs, because that's what you're here to learn. So for us to talk about the future, we should talk about the past. So lots of Java started way back. There is a lot of, and there continues to be some really good advice on how to design software. And a lot of it is around a thing called Solid, which you can go Google for. But if you look at the Java doc for AWT, which is a really good example of how we used to be taught to create Java code, there are a lot of holes in it. And we're going to go through some of those and others. And then I'll talk to you about how we can fix some of these things because of the new features we have. When AWT came around, was created right at the beginning, there were a particular mentality about how you create APIs, and there were not the controls that we have today. Okay, so when you've got this design stuff done, and you think you've got a great API, the other thing that happens is version 2. Right, you've built version 1, and then suddenly you've got to build version 2 because you've got to change it. Right, and Solid has nothing. Nobody talks to you about how to design upwardly compatible APIs. I'm going to cover some of that. It is a challenge, right? Because when you're thinking about the future, it's hard to imagine. You might have a list of features that are coming in, but quite often what you want to do tomorrow was not even thought of today. So, if you're Romans trying to get to the moon, it's, oh, this is a new challenge. How on earth do we do that? Okay. So we recognize that the past is past and you've created some APIs and now you have the next version. So in theory, though we may not get it right all the time, as Java developers, you probably think you know what you're doing, and that even when you get requirements that you wish you'd known beforehand, that you can deal with them, right? Well, the problem is, which is why I said I do talk about security and I'm talking about API design, is that when you look at the distribution of what breaks, so you go to Maven Central and you can download all these components. And you know about semantic versioning, the 3 dots? Okay. So the promise is that the third one, the lowest one, is for bug fixes. So there should be no API changes, no breakage to your end user code. The middle one is about new features, but no promises of no breakage to the API. And then the main one, the one that's 1 dot, 2 dot, 3 dot, is where you're supposed to indicate that you have changed things so that if there are breaking changes, your end user has been told because they can see the version changes. When you look at that in reality, it turns out that it doesn't matter which of those 3 dots you pick, the likelihood of that download breaking your API is the same. So even if it says, it's just a bug fix, there is as much likelihood of it breaking as if it had been a major change. Right? Because lots of people don't understand how you can change things, or rather when you change things, that it's going to break. Right? So we need to do better, right? The semantic versioning thing is there to help you, but it doesn't help us because a lot of the time we don't know what the problem is. So I want to ask you some questions, get you involved, because I want to get some feedback, right? So we're going to talk about your understanding of how Java works, and then I'm going to talk a bit more about how we're going to use modern stuff. Right, okay. So when you start to break down what causes these changes, right, there's the inadvertent changes, which is probably most of them, and there are other things where people are deliberately breaking changes, right? Move fast and break things, right? So people who are trying to expect to break the API will probably signal it correctly. It's all the people who've created code and then they've changed it and they didn't realize it had broken, right? And the reason that this happens, the reason that you might be blindsided, is because partly of the way you operate and partly about your understanding of how Java works. So there are actually 3 times. There's IDE time, there's runtime, and there's compile time, or IDE time, compile time, or runtime. Right? There are 3 ways that you interact with Java code. Okay, I'll press that button too. Right. So at IDE time, images from ChatGPT, so not my IDE, you get these hints, you know, so here's interface tree streamer, it's got the wiggly line, I'm sure you've seen all this, and basically what IntelliJ says is, this is a raw thing, you haven't parameterized it, you should do something about it. So the IDE is telling me I'm making mistakes, I should do something about it, right? And it's all over the place, isn't it? So it'll tells you what things return. You get this wonderful information about what your code is actually returning, which is awesome when you're coding. Right? You get all that feedback. So there we go, build.stream, and then I map it. So it's got stream.object, so I want to turn it into files. So I do some clunky mapping to turn the object into a file so that it now says stream file, and then I do a filter, you know. So I'm sort of, that's not the great way of doing it. So what the IDE encourages you to do is to parameterize it. Use generics and put a thing in it. Yes? So that's what you want to do. And that means that code which had stream object now says stream file. So now I don't need that middle line because I don't have to map it, because that was just to get the IDE to tell me everything was okay. Okay? That's cool. Like, okay there. So the IDE told me some things. I fixed them. I went, hey, cool. I've made progress, haven't I? The trouble is, this is all fake, right? So here is my code, right? There's my interface, and here's a trivial implementation of this interface, and you can see the stream F. So this bottom one, tree streamer, streams files. Right, it doesn't really do anything, but you get the picture. Okay? Okay. The problem is that it's fake. It's generics. It gets erased. So you look at the top one, so you've got public stream. So the IDE is complaining about raw types, which it's allowed to. But there's nothing to stop me or somebody else doing the middle bit. So you can see this. Stream of new hash set, right? So even if I was to create something that says I'm going to return as things of this type, my code or somebody else's can return of things of any type, because it doesn't make a difference at runtime, right? So that means the code that I came up with, which said, oh, I've taken out this checking, this mapping, is dangerous. So I actually need to have something in here to deal with the fact that the objects I'm streaming aren't necessarily the things that I want. Okay? And because you use the IDE to give you this information, you can often get misled into going, oh, I've got to operate that. I fixed it. But you haven't fixed it. Generics are all, the object types get erased. Okay. Right. So they're good to help you think about things, and they're good to having clean code, but they're not defensive at all. Okay. And then let's talk about compile versus runtime. Okay, so this is where I'm going to ask you questions. So this is slightly complicated, so bear with me. So here we are, JVM, some dependencies, of some API that I've written, and then a user code, the people calling my code. So there's my stack, and it's all being compiled lovely. Okay, but what happens if I switch the base to a new version of my API? So the user code hasn't changed, but at runtime, I've changed everything. Okay, I've moved to a new version. So if I have two versions, so the top line, public int method A returns 1, that's version 1, and now I've replaced it in my second version by making that method private. So the question is, if I do that, does it break at runtime? Does it break at compile time? Who thinks that will break at runtime? Okay, who thinks it will break at compile time? Okay, which way do we go? Does it break at runtime? No. Does it break at compile time? Mostly yes. Okay, because the compiler will say there is a method missing because you've hidden it. Perfectly, you know that one. Cool. Okay, right. What happens if I change the return type? Version 1 returns an int. Now I've changed it to return a double. Does that break at runtime? Does that break at compile time? You're like, I don't know. What happens? Doesn't break at runtime. Sorry, it does break at runtime. It may break at compile time, depending on whether anybody's using the return type. Right? But at runtime, it fails because that method no longer exists because you changed the signature. Okay. Another one. How about if I have returns integer and it returns an integer object, and then I have a new version and I've made it superclass of integer number? Does that fail at runtime or does it fail at compile time? Fails at runtime? Fails at compile. You're not going to commit. Yeah, normally when I do this, nobody commits. Right? Okay, so what happens? Missing method. Right? It will not work at runtime, and compile time is the same thing. Depends what's getting used. The return type, exactly as described, whatever class it is, whatever primitive is in the signature, and if you change it, the method doesn't exist, fails. Right. Slight caveats to that, but generally this is true. Okay. What about exceptions? So I have a method that throws an IO exception, and then I change it to throw something else. Does that fail at runtime? Does that fail at compile time? Who thinks that will fail at compile time? Yeah, you see, you don't know. Who thinks it will fail at runtime? Okay. So, it will not fail at runtime. It will fail at compile time because it's got to be caught. They're not in the same tree. So if you're catching throwable, maybe, but generally, right, you won't. Runtime doesn't care because of the way JVMs work. Okay, and the exception set is not part of the method signature. Right. So what happens is that you have all this throw catch stuff. JVMs don't care. All JVMs do is when they throw a method, when an error gets thrown, it throws it, looks up the stack looking for somebody to catch it. That's all it does. It has no relevance otherwise. So checked or unchecked exceptions, runtimes don't care. Okay. Yeah, I think that's what I said. Yeah. And I think I've said that too. Let's move on. Okay, I've got one more little thing for you. This is same solo thing. Version 1 of my code has constants, and it says string my constants equals hello world. And then I change it in version 2 so that the string my constant now says goodbye world. Here is my user code that has been compiled against version 1, and it prints out the value of constants.myConstant, i.e. whatever it says. Which of those two values is it going to print out when I've replaced the thing it was compiled against, version 1, with version 2? Who thinks it will print out the new version of goodbye? Excellent. Well done. Who thinks it'll print out the old version? Okay, see? Cool. Okay, a few of you. Ha! It will print out hello. Why? Because the compiler will inline the value of those constants. If they're primitive or strings, the compiler will inload it. So if you use strings like this to signal information, assuming that if you change the version, it'll all work happily, it doesn't, because that system.out.println constants.myConstant isn't actually what the code does. The compiler has replaced that with some inline thing it's stuck away in your code. So when you change the dependency, that doesn't change. There are lots of little bits like this, and they bite you. You have to understand the difference between compile time and runtime. Right? It also means, because these things are easy to forget, that you're testing, if you're going to be delivering version 1 and version 2 and version 3, that you have a testing infrastructure set up so that you can construct those sequences of running old code against new API versions, etc. Because it's the only way you're going to prove to yourself that it works. Because if you've got an IDE and you refactor stuff, you can easily refactor all the tests as well, right? So if you're serious about maintaining API compatibility for the future, think about how you're going to test it at a binary level. Right. So how do we do something different? How do we get rid of this mechanism? Because there's obviously what we've been talking about, I've been talking about, is there's some basic problems with changing methods and things like that. But there's a behavior problem, right? The behavior thing was the user of these classes assumed that you, the user, knew what you were doing and would do the right thing. Unfortunately, that's not true. You will do the wrong thing, or you'll do the right thing, or you'll do the wrong thing for the right reasons, etc., etc. And it's because we don't think about how we design code unless we think about it from the solid point of view. So I want to give you an example. The way you should think about designing APIs is that you should separate the contents into 3 buckets. You should think about the policy, you should think about the process, and you should think about configuration. We'll talk about, so what's policy? So imagine you've got a washing machine or a dishwater or whatever it is. You're at home, okay? Policy is when you say to the machine, here's what I want you to do today, this instance. Okay? Process is what it does. But in our own ways of writing code, like AWT, it was like you could have the opportunity to put your hand inside this when it was washing, because of the way that we let people override classes, instantiate interfaces and things. Because the assumption was that if you were going to want to have a dishwasher do something, you knew what it had to do. But that's not how real life works. Real life says, I want to keep the user away from the process as much as possible. Certainly you have input, but you don't have control. So policy is, what do I want you to do this instance? Process is what your code does. You want the user to give you a policy that you can then use to drive your process. And that might include a few bits and pieces where they have some input, but they're not part of your process. Okay? And then the third one, which is config, is usually the bits of your API instantiation that aren't going to change the time that it's running in this JVM. Right? So the config for a dishwasher is going to be, hey, do I have hot water or cold water? Do I have both? What's the drainage? Right? That's it. That doesn't change. And you certainly don't want your end users to change those things, right? You set it up, it's done. So with that in your head, it begins to get a lot easier to create APIs that are robust, because if you follow that idea, and then you start looking at how you can code it. So let me just do this in code again. So with that whole idea, so I have an interface called washing machine, blah blah blah. You know, you can see it as, and I have an abstract class, abstract washing machine, because if we're following AW2 rules, that's what you have. Interface, abstract thing. Pretend it's got code, right? It doesn't have code there, but pretend it does. Right, okay. Right, now, the user code can override that because we've made it abstract. We can't make it final, of course, because we want them to override it. Or they can actually go and implement the interface themselves. Right? So if your API says, here's an interface, do whatever you want, that's not particularly useful. If you have an abstract class, you're saying, I can do some of the stuff, I'm creating the process, but I'm leaving gaps for you to fill in. That doesn't work either because, well, what can happen? So you can have the user go, I'm going to replace your process altogether, I'm going to have my one. Or it can take your process and subvert it, right? Do the washing thing, I'll do it my way, right? And their code has to understand how your code works, because they're subclassing your code. And if they're creating an interface, if you're saying, give me an object that interface satisfies this interface, they've got to know a lot more about how they're going to get data out. You know, what's my responsibilities? It's not codable. Right? What comes next? Yeah, and yeah, I've said that. Yeah, okay, and they can break it. Right, water softener. I mean, so imagine water softener gets called as part of wash. If they replace wash with their own one, that doesn't get called. That may or may not be a problem. But you call a method and it gives you back something you're not expecting, they've just broken you. This is what breaks you more than anything else, because you let people do things with your code that you don't really want to do, and you want to lock it down. So how are we going to lock it down? So we're going to throw this out, right? This approach is no longer necessary. You do not have to have subclassing. You don't need to do that, right? You might occasionally, you're going to make use of it, as I'm going to show you, but it's not really what you need to do anymore, right? We have too many other ways of giving people interfaces, APIs. Okay, so here's another way of doing it. It's called sealed classes, which have been around a few versions now. Anybody using sealed classes? Oh, you should all put your hands up. Okay, so what are sealed classes? So I have a sealed interface. Okay, it's called I1. Sealed means I'm telling the compiler and the runtime, this is enforced by the runtime, that the only class that can implement I1 is called C1. And then you see the next line, it says public static sealed class C1 implements I1, permits X1. So that one says I implement that, I1, and I'm also going to allow another class to subclass me. And X1 is down below, okay? So this first few lines have said this interface lets me control who can implement me. Nobody random, just my stuff that I want. And also the same with classes. Okay? And so then you've got the class X1, right? It's got a private, so if you set it up with a private method, private constructor, right? You've now locked everything down. So at this point, nobody can create your code. Nobody can create your code because you've hidden it away behind private constructors, right? And you've prevented anybody subclassing you, so they can't get into your process, right? And so once you then add a builder, you can have build processes. So build in here. So that's where your process takes place. You can create instances of whatever objects you want to produce, whatever interfaces that they're going to implement, but you control it. The starting point for your API starts with the builder pattern rather than asking people to implement interfaces. So let's look at this in more detail because there's a lot here. Okay. So I've got navigator policy. It's sealed, it permits abstract navigator policy, okay, blah, blah, blah. And here's my abstract code, okay. This mechanism allows us to, the sealed mechanism that gives us that control. And now you can start thinking about using these relationships to build what's called build the policy. What do I want you to do today? Okay, let's go to the next slide. Okay, so inner classes. So using permitted inner classes. Okay, what am I saying? Using permitted. That's not what I meant. Okay, so actually, let me go to the next slide because it's probably a bit more sensible. Right. What I'm trying to say is that you can create an application and you can say to the end user, to use my application, you have to use a builder. Now, in some instances, the builder may just be a public constructor, but in theory, anything complicated, you could do it this way. So, what have you got? You've got an application. Okay, it's got a private constructor, so nobody can instantiate it. You've got a builder. You have a builder class. Okay. Which itself has a private constructor, so the builder can't be instantiated. Okay, and then your app class, wherever it is, has a builder method. Is it on there? Yeah. So your application can return a builder. Your application is the only thing that can construct the builder, so nobody else can do that. And then your builder has a set. It is the thing that actually constructs the application, and then you use methods to use the builder to configure your application, to apply a policy. Okay, and then of course when it's finished, you have some builder, and which is the middle set, and you return an instance of the object. So you've constructed an object using the builder that nobody else can do. You have complete control of how this thing gets created, and it's as complicated as you want it. So I use this a lot now. So this is a policy type thing, right? So I've got a builder. So I have this class called navigator builder policy builder. Okay, and it creates, so there's the builder, and then you can see rate limits. So that's a policy. So my end user can build this and tell me what policy I should follow. So this is navigating through trees and things. So look, a rate limit. It's on the builder. It's not on the tool that they want to use. Okay, default values. And then with the use of inner classes, you can start to build quite complicated DSLs, and you can see from the faint grey coming back, like match config, that the compiler, the IDE, is picked up on what your return types are and will help you at the IDE level fill the right things in. Okay, this is your API. Your API is what you use to construct policies, and maybe then use the policy objects later on. But you can, with the use of seal classes and the use of what they're called, lambdas, sorry, and inner classes, you can build APIs that look like this. And this you can change without breaking people, because all you've got to do is there's a new builder, right? So you can map CLI type structures. I mean, all the CLIs you see with command, parameter, sub-command, but you can build those in this. This is what your end user can use. And by creating this so that you've got policies, okay, so I've got some really complicated ones coming up, but look, here's a stream visitor builder. I get a configurator, which is my builder in this case, and I give it a policy. So the policy is another object that has gone through this, which has got some settings. Okay, and then I've got other things like select. So it looks like a DSL, but it's all just inner classes and fluent approach, right? And as you can see, right, it readable. You can see what's going on, and because I've got lambdas, I can put into my policy a little bit of code, and that little bit of code has no access to the outer process. It's constrained. It's whatever you want it to do. Whatever it's going to do is whatever it's going to do, but it's going to do in your place where you know it's going to do. It has no ability to get at the application because the application doesn't exist yet. This is just configuration. Okay. I think I just said that. Yeah. And so those user code means they can't break out. It's not like the methods where it's in a subclass where you've been asked to fill it in and you know it's going to get called, where it's already can go off and figure out what its parent object can do. Right. This means it's completely removed. Right. Okay. So I think we've got most of that. So what could run some of this through us again? So things like final, you should always use final. Yes. But what you've got to understand is that when you declare methods on your class for the very first time, the public list, that's your API. So you can't add new methods to your class, public ones, okay, because you might clash with the end user. So your API space is whatever you declare. So if you have a version 2, your API space, the list of method names and signatures, might clash with somebody that somebody's created on a subclass. Right? And so if you make things final, you know that people aren't going to subclass you. I mean, subclassing is just stupidly bad in these examples. Okay, but because you don't create things as final, people do subclass you, even though you don't realize it. And then what happens? You do a version 2 and you get a clash. There's all sorts of places where that can happen. Okay. So that's why I say you start to look differently at creating these things. So you look at creating APIs, you look at having control over things, how they're created. It might be on may just have one constructor that takes a policy object, or it might be the builder pattern, right? More water. Builders are really cool because of this mix of what the IDE does for you and what you can do in terms of inner classes. So, same sort of thing. You've got an API builder. The builder returns a configure in this instance, and then the configure class is a private constructor, so nobody else can construct it, right? And it returns this. So configure returns this, which you can then use to use Fluent, so you can build the DSL. Okay, and at some point you have one at the end which says build, create me the thing. Okay, it's really trivial to do, and you can do some really complicated stuff with them, as you saw. I've got 7 minutes. Oh dear. Okay, so a few other things to tell you that break you, that may not break you now, but will break you tomorrow. Obvious things like primitives. Don't do this, right? Because, well, use enums. Enums are so much easier to control and extend, right? But the thing I want to remind you is every primitive that you have in your application or in your API, unless it really is a number or it really is a label, it's actually representing something else. So you might often get people have strings that are zip codes. So just create an object, because you'll like that in the future. But if one day you come along and go, I need to that string we've got, I need to do something more with it. Okay, you have no options. Do not use primitives unless it absolutely is a primitive. You will get no penalties performance-wise by using objects that you create to represent this data than if you used just primitives, right? JVMs can cope with that. Yeah. So you've got the steel classes stuff, which I think I've said loads of times. Yeah. Yeah. And then you can build very sophisticated DSLs, right? But look, you can see all the grey stuff. You can navigate my DSL because each part of the API of these inner classes, they tell the IDE what's coming back, and therefore you can build this stuff, right? And then the other thing that's going on here is I might allow methods in to do some sort of be part of my process, but very constrained. What I'm trying to get to the point is where, what does this do? The policy gives me back data, and it gives it back in a streaming form that the end user can do whatever they want with the data. So the policy says, here's what I want, here's how you should go and get it, maybe a little bit of help with filtering things out, like whatever, but what comes back is streams, not arrays, not collections, just comes back as streams, of which I can then go and apply all the streaming that's there in modern Java. So you don't need to cache stuff, right? You don't need to create sets and arrays. You just need to start streaming, right? Because then the end user can do what they need. And they say, if you use a policy process of being able to take in some filtering or whatever it is, some transformation objects or something, they can go into your process part of your application, right? And that's safe. But you return the data that they want, and your end user then applies whatever business logic they need to, right? You've done your job. You've given them what they needed. Okay. APIs certainly have simple extendable mechanisms, right? Complexities in the builder. You don't have to break the API, because the API, if you have an API that returns data, that's all it does. It returns data. There's no mutators on it. It just returns data. Okay. If things get really complicated, then you can start building complicated things like this. So sealed interface, page config, permits, page selector 2. What's going on? So I have a record. New thing, record, right? And the record has a bunch of fields, and it implements page config. Okay, so I have a record that implements page config, and then, rather than have a get data or whatever method with 10,000 parameters on, and now I want to add another one, which is a usual place of breaking, I can say, no, I will take an interface, and that interface, there's only two instances of that, or two instantiations of that interface, and they're both records, and they're both sealed, so they're my records. And then all I've got to do if my page config requires more parameters is to create a new type of record and join the dots. So it's so much easier to do things that your end user can't break. So I whirlwind through that. I hope you got it, because we had like 45 minutes. The takeaway here is that we've all been trained on designing Java APIs from a very historical point of view. We talked about object-oriented design. You don't need to do OO anymore, right? Because that relationship is no longer necessary. You can use it internally for sure. You can use inner classes and things to give you relationships. You can build some really sophisticated DSLs by using inner classes and using the fluent mechanism. But you don't need to use a lot of the ways that we've used in the past that break. And if you pay a little bit more attention to, for instance, not using primitives, so the reasons that you might break an API is because something needs to change. The number of times I've seen people go, hey, I have a Boolean, it should be true or false. And then in version 2, somebody says, yeah, well, I want a third value. You know? So don't use true or false. Create a class or an enum or something. Do it up front. You don't need to use primitives unless it really is a number, right? And also think about ranges. So often you see people going, oh, this thing will only have 10 entries. And then next version, somebody wants 10 billion. And you have arrays that blow out of space, right? Or things like that. So the answer is don't do that. Get away from using sets and using arrays. Use them internally if you have to, but never give them back, and just go for streaming, because your end user knows what they want. And if you set it up so that they provide you the policy for giving you data, they have no need to be part of your washing machine. right? All they have to do is go to the dial and go, I want a hot wash. Press button. Okay? Everything else happens. And you can do that with modern Java, whereas before we couldn't. That's it. Thank you. So have we got questions? I don't know. Are there any questions here? Or are we supposed to use this solo thing? Hands up, sir. No. If you have an enum and it's got 5 values and you put a 6th value in, that's fine. Don't insert one, but put one on the end. Yeah. Enums are just magic class lists, object lists.
And if I use the enum as a return value of my API,
yeah,
then the user may switch over it, and if he does not have a default.
So yes, so if you add to an enum and then the user's passing it, then yeah, it could do.
No, if he uses default as he should.
If he uses default, yes. If he uses default, yeah. Oh, you can certainly still break your end user, but the point is that this removes that inadvertent breakage, especially like method signature changes and things like that. And you saw with Erasure, if you don't understand that if you've got generics in your system and that means nothing. Right, it's fine at compile time, but at runtime it could be anything. And if you don't code to that expectation, you're going to get broken. Right, it's as simple as that. But if you start separating this out and going, okay, I want objects. Right, it's my code that's getting the objects. Right, I can deal with it. Right, you're not. It's that whole washing machine thing. Right, that's the thing to take away. Separate out how you think about designing. So that you have configuration, which is the things that aren't going to change, right? They're just values I might pick up from environmental variables. I'm going to have something that survives for the life of this JVM, and then I have policy, which is just for the this call, right? You have one class could be I've got this policy, and then somebody else may want to use your API with a different policy. The policy tells you how to operate, which you can follow, right? And they're not involved with your code unless you let them. And if you let them, if the involvement with your process is via lambdas, they can't reach out, right? They have no it's just a piece of code. They have no context within your application. And that's really powerful. They only use what you give them and you use what they give back. He's doing it again, yes. Why don't you use the module system? I would love to tell you that there are some really cool stuff you can do with modules to provide security, and it's true, but nobody uses modules. Who here is using modules? So I will tell you, I don't know if you understand this, but modules are one of the primary ways that the Java team are delivering security features and things like that. They expect you to use modules, but nobody does. So you miss out on a bunch of stuff. But you're right, there are things you can do. Yeah. Okay. Any more? No, he didn't. Okay. So obviously we've got this evening. I'm around tomorrow all day. If anything comes to mind, just come and stop me and we can have a chat. Thank you.